All right, let's dive in. Today, we're going to talk about a really radical idea, one that kind of messes with our whole black and white view of the world, at least when it comes to logic. We're going to see how one thinker introduced a totally new shade of gray into the very idea of truth itself.
So let me ask you a question. Is every single statement you can possibly make either true or false? The sun is hot, that's true. The moon is made of cheese, well, that's false. Seems pretty straightforward, right? But what about a sense like the current king of France is bald? Or how about this one? This statement is a lie. Do those really fit so neatly into a true or false box?
For most of history, logic was what we call bivalent. Every single statement had to be either true or false. No exceptions, no middle ground. But today, we're exploring an alternative called the third way, which has the guts to ask, what if there's something else? What if there's an answer hiding behind that question mark?
To find out, we've got to go back in time. We're going to the very moment this third way was born. And like any great revolution, it all started with one person and one really groundbreaking idea.
The year is 1920. Our main character is this brilliant Polish logician, Jan Łukasiewicz. He publishes a paper on three-valued logic, and with it, he basically sends a shockwave through the entire world of philosophy and mathematics.
So what is this idea he came up with? Well, it's pretty much what it sounds like. It's a system of logic that introduces a third truth value. It doesn't get rid of true and false, no, it just adds a third option to the mix. And in doing so, it opens up a whole new way of thinking about statements and, reality itself. Now, this wasn't just some isolated, quirky idea he had. It actually created a whole new category of thinking. It's like a brand new branch sprouted on the family tree of logic. You see, Łukasiewicz's system is what we call a non-classical logic. It's part of this larger movement that was challenging all the old rules. It sits right alongside these other fascinating approaches like modal logic, which deals with possibility, or even paraconsistent logic, which can somehow handle direct contradictions. All of them were basically saying the same thing. The simple true-false model just wasn't cutting it anymore.
But to really get a three-valued system to work, Łukasiewicz had to do something even more revolutionary. He basically had to tear up one of the most fundamental rulebooks in logic, a principle that was established by one of its founding fathers. And this brings us to a strange but really powerful idea called Frege's principle. Now stick with me here because it's a little weird. It essentially says that a sentence like, "the sky is blue," is just a fancy name for the value true. The entire meaning of the sentence is just its truth value. Yeah, I know, it's a bit of a mind-bender, but it was an absolute cornerstone of classical logic. And Łukasiewicz's logic? It required a complete and total rejection of this principle. He argued that a sentence had to be more than just a label for true or false. This was a huge departure.
So here's how the new non-Fregean approach works. First, you just reject that old rule. Sentences are not just names for truth values. Done. Next, you say that sentences have their own unique meaning, what he called a semantic correlate. This then allows for the final, crucial step. You can build a system that reasons not just about whether a sentence is true, but also about what it actually means. This was a massive leap forward in what logic could do.
And this just goes to show, once you crack open a door just a little bit, you can't predict what's going to come through. Introducing a third value wasn't the end of the story at all. It was just the beginning of a whole new universe of possibilities.
Remember, we started here with the number 3, true, false, and one other little option, a simple, elegant addition that changed everything.
Because why stop there, right? If logic can handle 3 values, why not 4? Why not 1,000? Heck, why not an infinite number of values somewhere between true and false?
And that's exactly what happened. Łukasiewicz's work is now considered the foundation for the entire field of many-valued logic. And it's exactly what it sounds like, the study of logics with any number of truth values beyond just the standard 2.
Now, as you can probably imagine, this did not go over well with everyone. The old guard of logicians, they were not impressed. In fact, the idea was dismissed by some pretty harsh critics as the humbug of many logical values. They felt it was just polluting the purity of logic.
But despite the critics, the idea was just too powerful to be ignored. I mean, the legacy is immense. He gave us the very concept of many-valuedness, a whole new way to understand what sentences are and how we reason with them. And he laid the groundwork for countless other logical systems to come.
So, what's the big takeaway from all this? We've seen how a single idea from way back in 1920 cracked open the binary world of logic. And it leaves us with this really profound question. If the very system we use to reason about the world can have more than just two values, what does that mean for our idea of absolute truth? Something to think about.